Good morning, good afternoon, and good evening. Namaste, everyone. For what concerns the latest and greatest adds to our software suite when it goes to post-processing. And here's the agenda. So today I will be giving you the highlights on what concerns HyperMesh Post. This is our usual, let's say, way to go. Then handing over to Varun for the HyperView part, and then to Sandesh for HyperGraph and the reporting stuff. So starting with HyperMesh Post. When it comes to HyperMesh Post, I have divided my presentation into two major slides. I'm not going to go too much into demo mode, probably not, because I want to give some more space for Varun on the HyperView side, which I would say is the biggest highlight of this cycle. But when it comes to HyperMesh Post, I'm super glad to say that we are kind of filling all the gaps to bring HyperMesh Post up to the the big guys in terms of the supporting of all types of workflows when it comes to results visualizations and processing. In 2025, we have been finally release the vector and the tensor plot control to follow the deformation and to be part of the animations together with the contour plot and the marker plot. The beauty of this development is that you can also activate the vector and the tensor plot to be there either in the deformation mode, which is basically the default which is provided, but you can as well trigger to the plot control entity editor the possibility to display either or both vector and tensor plot on the undeformed shape. This is not, for example, available in HyperView as such, but is one of the requests that we have been hearing out and coming specifically from other competitor tools, specifically in the aerospace branch. What we also introduced is an explicit tag and option to activate or deactivate a small deformation. When we are dealing with nonlinear cases, the post-processing backend and the readers are capable to tag the result subcase and detect whether this results is linear or nonlinear. In the latter case, we have the possibility to, let's say, enable the possibility to deal with either large deformations or small deformations when it comes to the calculations of the intrinsic elemental systems of our model. As you know, with large deformation, basically the model at each and every time or load step change is elemental system. Therefore, the global to local transformation has to be recomputed based on this new calculation of the elemental system. When it comes on the other case, and this has been supported in the past in HyperView and is still available, if you have an OptiStruct nonlinear NLGeom analysis, or for example, a Nastran Sol 106, and you have 1D elements, then the only way to display the vector forces of 1D elements is to activate the small deformation flag, in which we are using the system at model, let's say, step for displaying the forces using the intrinsic system, the elemental system for the 1D. On top of that, we have also been unleashing this possibility through the results query. This is not as a flag on the subcase, as you see in the entity editor, but as a global flag that you can activate through the post settings. Last but not the least, in terms of the major announcement, this is kind of a personal campaign that I have started, and Varun will also say something more on HyperView multicore. We had done basically two things. we have been enhancing the labeling of the averaging methodology that we have always been exposing between HyperMesh and HyperView. And we made a decision, the tag from averaging to aggregation mode, meaning that we now have an aggregation mode, for example, summations or extreme and so on. But most important is that we have been changing what in HyperMesh Post was called simple average to an aggregation mode, which is now called average then compute. And then we also added the possibility to unleash or to evaluate the other methodology, which is compute then average. What does it mean? It means basically that if you have results, elemental results, let's take a tensor, and then you want to evaluate an invariant of the tensor, and then you want to do this by doing a change from the element to the node. In general, you have to do some averaging, which is a fact. But then because you have tensors which may be written in different elemental systems, when you want to sum the tensors, then you have to make the summations in a common system, for example, the global, and then you can evaluate the von Mises, being, for example, the von Mises and nonlinear functions. So a von Mises of an average tensor is definitely not the same of the average of the 4 von Mises or the von Mises at each and every element. This is the basic difference. And we are using this labeling change, and we also added the possibility to do the average at par boundaries or across par boundaries. So basically, and this was one major request, we remove all the inconsistencies between HyperMesh Post and HyperView to that extent. Other minor enhancement, we have been adding actually a satellite icon on the results ribbon to expose directly the post preference, so kind of reducing the number of clicks in this regard. One of the basically most requested feature was to add the rainbow color mode as default one. So when we display the results, they will come in a rainbow and not anymore in a divergent. We have been finally added also the complex invariant in closed form as well for the strain von Mises tensor that we missed in the previous release. And we also been adding the model percentage display to the deformation control plot when it comes to, for example, model or complex animation. Obviously, we have been working hard to enhance performances and fixing some other issues reported by our customers. But all in all, this is what we did when it comes to the HyperMesh Post for the 2025 release. So now, without any delay, I'm going to hand it over to Varun for what comes to HyperView.
So coming to HyperView, as Michele indicated, the major highlight of this release has been in the area of HyperView multi-core profile. So I wanted to spend the first few minutes of my presentation giving an overview of what HyperView multi-core is for those of you who may not be familiar with it. It's a sort of a reintroduction, if you will. So I will just first go over this, and then I will present what's been done in this 2025 release. So what is HyperView multi-core? It's basically a new profile of HyperView that offers better performance and improved workflow for results post-processing. Some of you may have already tried it. It's been there in this form since 2021.1 release, and it's a profile that comes up. There's an option that comes up in the launcher screen to choose this profile, and you can bring up HyperView multi-core. Beyond this short introduction, more specifically, I want to give some details of HyperView multi-core. It's better performing because it employs a multi-threaded asynchronous data loading technology behind the scenes. And that means faster load times and an always active application. So in a general HyperView profile, you may have noticed that whenever result data loads, The application is frozen. You cannot interact with HyperView application. You have to wait for the data to finish loading, and then you can interact with the application. But this is not the case with HyperView multicore. Not only multiple threads on your machine are used for data loading. One thread is always reserved for the application. That means you can always interact with the application. While the data is loading, you can make changes to your model, you can cut a section, you can do other operations. You can also intervene and stop the data loading. All this is possible because of this multi-threaded nature of this profile. And moreover, as icing on the cake, we have actually revamped the workflow here. So this workflow now offers greater user control on what gets loaded into the session. You can choose what you want to load, and that data gets loaded and automatically cached in memory and is always available for instant visualization purposes. You can also choose to unload data if you no longer want it to be stored in your memory. So all this is possible with the multi-core profile. So as you can see in this small chart I'm showing on the screen, this was an internal benchmark done on, you can see that in this particular case, we have about a 34% gain in total loading time. That's time to load the model, animate the results, and contour some results from the file. So overall, HyperView multi-core, to summarize, offers better performance and a much better workflow. Now, in terms of what's supported with multi-core, this is the information as of the previous release 2024.1. So the first in the first phase, what we attempted to do was support basically transient or explicit use cases, primarily in the crash domain. So accordingly, we covered 4 result files coming from 4 major solvers: Abacus, Radius, LSDyna, and PAMCrash. And we tried to cover all the post-processing features that would be required for these transient use cases. Now, what's next is we are planning to expand our coverage to now all the solvers and all the analysis types. We are planning to support derived load cases and derived results in the upcoming releases. And overall, our goal for HyperView multi-core is to make sure we have full coverage of all the post-processing features that are necessary to cover all these solvers and analysis types. So with that goal in mind, our development team has been working actively in this release 2025, as well as in the upcoming releases, to achieve this goal of full coverage of all post-processing features. So let me now go over the highlights of this particular release. As I mentioned, I want to mention like the 3 major updates we have done for HyperView multi-core. So the first one in this release, what we have done is we have expanded our solver support. As I mentioned, up to 2024.1, we covered only 4 solvers, but with 2025, we are now able to support OptiStruct, Nastran, and ANSYS results. So that means we have basically extended HyperView multi-core to cover many of the implicit solver post-processing use cases as well. And basically for these 3 solvers, we are going to support result file formats that they output. For example, OptiStruct could be outputting as an OP2 or a H3D or a FemZip file. We are able to cover all these variations. You can load also a model file along with the input deck, also along with the result file if you wanted to. And we have basic coverage for all sort of implicit post-processing features. So you should be able to load the model, contour the data, animate, view the animations, do all basic operations that you will be able to do with that are required for implicit post-processing. Next highlight, as far as this release is concerned, is again related to this expanded solver coverage. We now have the option to do a linear animation in HyperView multi-core. Up to 2024.1, HyperView multi-core supported only transient animation mode. But now we are able to do an interpolation-based animation. So what we are able to do is sort of generate animation steps inside HyperView to show linear animation. So with that, HyperView multi-core now covers linear as well as transient use cases. And next item is we are able to handle now multiple result files in HyperView multicore. So that means you can attach multiple result files to a single model file. So this is typically required in many customer use cases where they may have a multi subcase analysis, and for file size reasons they may be outputting one result file per subcase. So in this case, you're able to load a model file and you're able to attach all the result files coming from for the various subcases into a single into a single window. So let me now just quickly jump into a demo. So for those of you who may not be aware, this multicore, when it launches, basically you click on load data open model icon and you are presented with a dialog. So this is the revamped workflow, a little bit different from what you may be familiar with in HyperView general profile. In this case, we bring up a dialog, and in the dialog, the top section basically allows you to choose a model and a result file. So I'm going to just pick the FEM file as the model file, and for the result file, instead of picking just a single result file, I'm going to click on this button and I'm going to pick 2 additional result files. Like I said, each file contains a subcase or more than one subcase, but basically there are several subcases coming from the different files. So you can hit OK. And so the selection is submitted. And then at this point, you basically have to load the model. This basically loads this model and the result file you've chosen into the session. And once you load the model into the session, unlike the HyperView general profile, here we have a bottom section in this dialog, which is organized into tabs. The first tab is actually model tab. It kind of shows you a snapshot of the model information. So you'll be able to see like number of nodes, elements, and other information pertaining to the model. In the second tab, you have load case view. This is showing you essentially the load cases that are available for you to load into the session. As I mentioned earlier, in this case, we have 4 load cases coming from the 3 result files. So you have an option to either select specific load cases, or you can choose to load all the load cases, which I will do. Go ahead and do it. So once the load cases are loaded, the animation pertaining to those load cases are all loaded into memory. And at this point, you can start viewing the animations, close this dialog, and start viewing the animations, or you can go to the definitions tab. And here again, we have organized it into scalars, vectors, and tensors. So let me just pick maybe a couple of results. I'm going to pick displacement and stress. Again, you hit load selected. There is an options column here. By default, we are, for stress, we pick 1 mesos, but you can basically go into the dialog and choose other data components and layers if you wanted to. I'm not going to do that. So once you pick these 2, you can hit load selected. You may see a small message coming up here that data is getting loaded. And so basically this is a small model, so things are loading pretty fast. Just using a small model to make my demo a bit easier. But once you have the data loaded, you can see that we have in the main browser itself, we have a results folder. You can see that the 2 scalars that you're loaded are available as result definitions for you to plot. So I'm going to go ahead at this time and I can plot the displacement. I can also hit the animate button. And as I mentioned, we have 2 animation modes now. We have a transient animation mode as well as an interpolation based animation, which we also call as linear animation. So once you have the displacement loaded, you can sort of cycle through the subcases. And as I mentioned, the data is loaded for all the subcases that you have chosen to load. So everything is loaded and good to go and is stored in memory. So there is no waiting for data to reload. So overall, you'll have a very smooth user experience switching between load cases or between results. So I can go back and forth between displacement and stress without having to wait for data to reload. So everything is cached in memory and good to go. And here you can see that in the results view, there is a column that shows whether the data is cached or not. And like I said, this workflow provides you a lot of options. So if you do not want to keep this data in memory, you can always right click. You can say delete cache. So that clears it from the memory. You can keep the definition. You can choose to reload it later. So that's all possible with this workflow. And I'm showing everything through the browser, but you can also use the icons in the ribbon to drive this entire workflow. It is very similar to what you see in HyperMesh Post. So basically, you have a toolbar where the cache definitions are listed, and you can basically drive the whole plotting from the toolbar as well. So that's a short demonstration of HyperView multicore. So a few more enhancements and updates I want to mention here, not pertaining to HyperView multicore, but worth mentioning and worth noting. So one is the label change that has happened in HyperView. As Michele already went into detail, similar label change was done in HyperMesh Post, and we have done the same thing in HyperView as well. One thing here that one additional thing we have done in HyperView is we have actually renamed one of the computed results. These are we used to call this absolute max principle in earlier releases. That was a sort of a misnomer. So we have gone ahead and renamed it as extreme principle. This is also to keep it consistent with the labeling that you see in HyperMesh Post. And we have also introduced a new computed result called max apps principle. So both these are available now in case of any tensor data. These are computed results from HyperView. Again, these two results are available in HyperMesh Post, and it's now available in HyperView as well. And then coming to the averaging label change, it's very similar to what has been done in HyperMesh Post. So I don't want to go into too much detail here. Basically, we have renamed averaging as aggregation, and simple and advanced have been renamed as shown on the screen. One item we have done on the graphics side is to allow control plus middle mouse button, one click to set the rotation center. This was partially working in previous releases, but we have gone ahead and made the implementation complete, and it is now consistent with what is being done in HyperMesh Post or HyperMesh as well. And last item I want to mention is regarding the default fill color that we show for notes. Earlier we were showing a default color that was coming from the old HyperView. Now the fill color is updated to match or to contrast with the theme that you have set for your product. I think that's pretty much it from my side for 2025. I'm going to hand over to Sandesh at this point.
So, hello everyone. My name is Sandesh Gandhi, and today we will also go over some updates of HyperGraph and reporting. So, to start with HyperGraph, this release we mainly focused in HyperGraph on a few enhancements and bug fixes, while we are consolidating on also bringing all the HyperGraph functionalities in HyperMesh as well. So for this release in HyperGraph, we ended up adding a few more functionalities in the stack math functions. So in general, you will see all the single curve functions that were usually listed in the macro or math dialog. They are all available now also as a stack math operation. Which brings a lot of value to our users. You can pick any curve on the screen and use any of these functions, such as FFTs or even usual trigonometrical operations. Now, beyond that, we also decided to support .cur or curve files. They are pretty popular among LSDyna users, especially the ones who work with multiple solutions from multiple ecosystems. These files typically contain data from data for dummies or data for various accelerometers that you place in the simulation, and the data can be of the type displacement, accelerations, and so on and so forth. This was majorly done as per a customer demand, but in general, the idea will be now to extend this support not just to HyperGraph, but also other readers that are dependent on usually HyperGraph. So you can expect the same kind of detail also in Compose or any other solutions that usually provide you curve data. Now, in addition to that, we also continued on our journey to improve the user interface inside HyperGraph and modernize it. So far, we have already done modernization of our panels, and to continue on the same lines, we decided to this time also take a stab at vector charts tip to tail panel. Used to exist as a panel, but now it will be available as a dialog. And so does the table view overlay. So this also was a functionality that was available mainly as a panel. Now it's available as a dialog. None of these functionalities, vector chart or table view, none of them have any major change in the way the functionality works. It is still absolutely the same options that you are going to see on the screen. It is just that now it will be available in the form of a pop-up, so you can even decide to take that dialog on another screen and keep working on your main window if you decide to. That's the gist of everything that we have released on HyperGraph. However, like I mentioned, in the upcoming releases, you can definitely expect many of these functionalities popping up inside HyperMesh and bringing you, let's say, simulation-driven design approach and experience within HyperMesh. Now, shifting the focus to report. This time we are deciding to also announce the release of a new report module. And we could think of the existing reporting, and we can ask what is so new about report, right? Like we have been doing this report automation for a while. We have been talking about how report provides you access to all the formats. It works in batch mode, and it has some inbuilt modules that help you to automate report generation. However, we also realize that at certain point we are hitting the ceiling when it comes to performance, and also when it comes to being accessible to multiple applications within Altair ecosystem, and also being able to adopt the newer features such as GLB and even the 3D model that we are now exporting in the form of HTML. So in order to accommodate so many such things, we decided to come up with new technology behind the scene, which is going to allow us plenty of new things, and they are pretty exciting. One of the things that will be released with this will be flexible layouts. Now, so far you have always seen reporting relying on certain layout template. With the new report module, you will be able to use or continue to use that layout template. But in addition, if you are using the API, you will also be able to use some automated layouts, or let's say even set the object at a particular location just by specifying its X, Y coordinates and width and height. So if I wanted to place on this slide, if I wanted to place this image right here, I could have simply posted its X and Y coordinate and its width and height. It would be as simple as that. We continue to support all the known formats for publishing mainly. HTML is still work in progress, but the rest of the three, PPTX, DocX, and PDF, they are already there, and this is what we are releasing with 25.0. Now, another exciting thing is also support for equations. In FEA world, whenever we write reports, or even our users are writing reports, it's very typical to explain some calculations in the report. Now, instead of adding images, we decided to also support a way to add equations. Right now, in this release, it's going to be available as an API. But when we take this to a user interface, we are also working on some interface to provide you a way to write these equations. These equations are pretty similar to how LaTeX works out there. So you will see the API also works very similarly. And equations are supported for both PPTX as well as document. And when we take it to HTML, also it will be supported in HTML. Then comes even better USP of this new module, that is better performance. So far, we always, we have always highlighted the fact that report can take your hours of work into minutes if you have taken so many hours to write a report, we can automate the process to bring that report to you within minutes. But then we realized that users could be dealing with hundreds or thousands of images. Now with this new module, we have drastically reduced the export time. You could be seeing about 75% time saving just in export. This is different from the time it could take to just capture images or capture videos from your product. Even that technology must have come faster, but even beyond that, just the report export performance has improved so much. Obviously, this new report module comes with Python API. We decided to hold on to this Python API for a while. The API has been available since 23.0, and you will see when you open Inspire product, for example, the reporting experience that you get uses the exact API that I'm talking about here, which has better performance, support for equations, and all of this. But we decided to hold on to it for a little bit because we wanted to wait for also HyperView and HyperGraph and HyperMesh client APIs to come up in Python side. And now we wanted to follow it up with report Python API, because now the Python API layer has very well settled with its structure. So you'll see we are going to go over a quick script right after this slide. It remains to be independent of Office Suite. So whether you work with MS Office, Google Docs, something else, it doesn't really matter, because we just create the report for you, and it's you who decides whether you want to load it on Microsoft Office or somewhere else, or some custom application within your organization. And then finally comes the 3D object support. Now, although this image tends to tell you something about H3D, but even the GLB, right, the feature that we released last release with HyperView, even that is now supported with this new module, whereas it may not work with the old reporting module. And we'll see more about that difference, but quickly, let me take you over a sample script. So if I go to Python window and just open a script. So here I have a certain script that we have created with the existing API, the one that we are releasing now. What it has done, it has assumed that there are some images already created somewhere, and then it tries to create a few slides, about 7 slides to be precise, and then it tries to take into account some imported layouts, the layouts that we are reading out of existing layout template. It also tries to use some automated layouts. Automated layout means if you take a slide and just add an image, it will be automatically placed at the center of it. And if you add another image, both the images will be placed according to their size, and you will not have to probably tell where to place an image. It will automatically understand where to place it. And beyond that, you also have manual layout, where you just specify X and Y coordinate and width and height of the object you want to place, whether it's table, image, text, whatever it is. So I'm going to go ahead and copy this path, take it to my Python console, and run this. So when I run it, I'm going to see the PowerPoint quickly popping up. For 7 slides, it doesn't take much time, and it's going to be faster, even faster than the legacy report. Now, I'm not going to go into presentation mode on this, but you see this was the automated layout where we did not even specify where to place the image. It just detected where it should go. So this is the power of the new API that you are going to get. This is the one with imported layout. So if you look at the layout assignment here, now you'll see that a certain layout was applied here. Same goes for this one. Certain layout was applied here. Whereas if I go back to this one where we were using some automated layout, it wasn't really using any layout here. And still you see 2 objects properly placed. So that's the nice thing. Now about manual layout. This example was intentionally messed up to show you the effects of manual layout. You have to use it with caution. If you do not have a good idea of where to place things, it's always better to use layouts. But whenever you want to manipulate things, there is always a way to change things the way you like. So in this case, I was able to place a text or text box, a table, and an image properly on the screen. But if I had not placed it correctly, something like this could have happened. So there are good things, and there are obviously some precautions that one is supposed to take when they are using manual layouts. The goal of this this discussion is to announce this mainly for our customization projects. Because I know that we have been using for a long time the API that we have been using through the legacy reporting. Now, on this slide, let's quickly look at the similarities and the differences of what we just saw. For a long time, inside the product, you have been looking at this report ribbon, right, which has this predefined report, has the browser, and a few other ways to add modules or individual images, tables, and text. And you could obviously switch to PowerPoint mode and add slides as well. That is what we are calling legacy report. It used to be called ARD in the past, 5 years ago precisely. And now 5 years ago, we decided to bring that functionality to all the users through HyperWorks. So the main difference really is the one that are highlighted. That new report module is going to be pretty fast, and it's ready for consuming data from variety of Altair applications. So you could be working with that common Python API, and you could be working with HyperMesh Python as well as maybe Inspire or some other Python API. And this reporting service could take the data from anywhere. I mean, that's really the end goal of this new service. The layouts, we just saw how flexible they can be. Although, in this script, I had to really explain you how things can be flexible. When we take it to the user interface, when we decide to build a GUI on top of these APIs, we'll probably curtail the ability to edit the layouts too much. But there is always going to be this functionality behind the scene that is meant for our customization projects or ESG projects. Then the supported formats. For a long time in the legacy report, we used to create HTML reports, but first a document used to be created and then HTML used to be generated. So when it came to layouts, we used to depend on docx API mainly. With the new reporting module, we have already seen the gist, or let's say a glimpses of HTML, right? You have been seeing a 3D model getting popped up on the screen inside an HTML. It's a very similar functionality. That's exactly the teaser that we wanted to provide. But in the upcoming releases, you will see a way to directly generate HTML files. And the layout can be out of PowerPoint or docx. It won't be just locked to docx anymore. And it will have a few other things. So when we get there, I'll definitely go over those functionalities in more details. But for now, let's decide to focus on PPDX and docx. It is staying independent of platforms, like I mentioned earlier, and we are deciding to support advanced objects as well. We have seen the glimpses of H3D and GLB already. Equations was something I was talking about today. Performance has improved. And if you wanted to write modules, 25.0 onwards, you can write modules and also register them just as a plugin, just like any other Python functionality that you could have in HyperMesh, just like many other things. So that was another idea, that we wanted to make our API layer for reporting as close to our product API as much as possible. And I think we have been very successful, and really thanks to Stefan, Dimitri, and our entire development team for bringing this change together over here. Now, one big precaution while I'm explaining this is to know that the current user interface that you see in the product, it is still based on the legacy reporting. So if I'm running any reporting workflow here, you'll definitely see the HWC console also running certain report lines. They are meant only for legacy report. They are not yet connected with the new reporting. So when you run a new project with this, please make sure that you are not using this GUI yet on your automations. But obviously, some sort of GUI or a very similar GUI will be coming very soon. And the idea is to really replace the legacy report and just take over the entire reporting with new report module. But eventually, this is going to be your resource for long term. So really, there are many features to look forward to, and there is obviously a long-term goal behind this reporting module. Now, moving on to our next feature under reporting, which was about 3D model export. We have gone over this in 24.1, so this is just a quick recap. When it comes to 3D model export, I was talking about earlier that there are reports which will need 100 or 1,000 images sometimes. 1,000 images is pretty typical of AEC workflows or AEC reports, but maybe for other structural reports, maybe hundreds or 200 images is pretty typical. But that's what we wanted to change drastically, and that's where we wanted to provide just single 3D model that answers all your questions instead of putting 10 images for the same object. That's where 3D models were pretty important. And we provided a light view and a rich view. Light view had a simple goal, provide data portability and minimum viewing dependencies. Whereas with rich view, we provided a viewer along with the file we provide, and because we were owning the viewer, it also had a few extra functionalities with it. With light view, the GLB files, you could directly view it in Windows-based viewer, or you could even use it in the AR, VR applications. You could embed it in PowerPoint. The demo that we see here, this already uses the new reporting API, by the way, but that's an example of how the advanced objects are already supported. With the rich view, when and you're referring to H3D, whenever we say that, there was always a functionality to view it with HyperView player, and then you could always embed it in PowerPoints. But in the last release, we also released a new viewer that we used to call Altair 1 based HTML, which used to work in all the new browsers. Now that was the release that we made in 24.1, and there was a point in repeating that, but in this release, we basically stressed on making it ready for automations. So especially for GLB, we decided to focus on legend modifications, a customized legend. So if somebody is trying to automate a process on their server to say, change the legends in a way that if you see a GLB file, everything that shows up in red is always your failure region, and everything that shows up in orange or yellow, that could be your warning region, and everything else is safe. So if you wanted to say that, well, that could be, you could make those changes to the legend and it could get exported easily. This was a new feature for us. And then in addition to that, we also decided to add a new option called skipping the model hierarchy. What it will do is, if you have a model that has a large number of components is a very HyperMesh or HyperView terminology. We are already trying to move on to parts. However, if you have components, and there are many of them, in GLB, if you had opened it in a third-party viewer, you could have seen a model hierarchy. But obviously, when we see it with Microsoft 3D Viewer or inside PowerPoint, you don't get to see that hierarchy, and there is no point of keeping that hierarchy there. So we decided to provide an option to skip that hierarchy, and it ended up saving a lot of things for us. It first of all made the export pretty fast. So if you have typical aerospace models where, because of the way we arrange our data, there are a lot of components, and there tend to be a lot of components. We can actually jump into an example on this. You will see 24.1 used to take a little bit of extra time for such examples, but now in this release, you will see those exports happening 75% faster, and at the same time, the file size has drastically reduced. It can be reduced up to 90%, but it also depends on how many components per elements you had. The one example that we can go over can be, one of the worst cases. In addition to that, we have decided to release a Python API, which Stefan and Dimitri have already gone over along with Mikal during automation JDA. Similar story on HTML export as well. We had some minor feature upgrades, again, meant for automations mainly. This time we decided to make the look and feel of player inside HTML more close to HyperMesh or HyperView. So ViewCube will interact with you in a very similar fashion. The query table preferences, they will pretend as if they are the same query table inside HyperView now. So there will be a context menu. You can hide and show some columns there. And also, as long as you are in the same HTML session, it will try to store. So we were looking at this window earlier. We ran a Python script, but I also had this model on the screen, right? So this is a model where I have some 24,213 components, just the way we arrange data here. But really, the elements, we have 24,000 elements about there. if you run this example in 24.1, you will see we used to take about a minute to export it, and it used to take about 10 to 15 minutes to just open this file because of the way it was structured. If you now run this in the new release, you first of all get to skip this model hierarchy. And when you export it, I'm going to say Wing 2025.0. Yeah, to overwrite it. So it opens the file right away. Right. So when it opens this file, first of all, you will see that the one file that we used to create with hierarchy used to take about 180 MB. This you have about 20 MB. So that's the amount of saving we are looking at. And at the same time, you saw this file open pretty quickly. So that's the saving you're getting. Now, at the same time, if I maybe an example like Wing frame variant, again, using some aerospace related example here. So I have example like this where let's just apply any contour for that matter. Let's take it to HTML. So nothing changes on the HTML side, but when I export this and decide to say in 2025, it exports it pretty quickly. And when it opens, so this we have seen before. You can obviously run the animation and see the displacement for yourself, and also apply a scale if you wanted. So you could now see with a 2200 scale what it could look like. But really coming to the callouts. So this was the preference table that I was talking about and the view cube. So I could be clicking on certain entity to see its value and the part name, or I could be typing in some node ID or element ID depending on the type of result you're processing to see its values. Now, when I say 150 as the node ID, I could also just activate it as a column. So the idea is that when you enter the ID here, it's going to show it here. But if you just pick it with the mouse click, it tries to interpolate even between the two nodes to give you the interpolated value. So that's why it may not show you the node ID all the time. But then obviously you can always decide to hide things and even close this. But if you come back to it later, it's going to remember your preferences. So these are some minor updates we have done. With Python API, this becomes even more than ready for you to take it to automation processes and help users set up some automated reporting solutions. So that's it from a reporting side as well, and in general, HyperView and post updates. Thank you so much for your attention so far.